Hello everyone. Today we are going to be discuss gear train, and before starting the subject I would like to introduce myself. My name is Dr. Irshad Ahmed Khan, Associate Professor in Department of Mechanical Engineering, Sagar Institute of Research and Technology, Bhopal. So let's talk about this topic, gear train. So gear train is a two or more gear walking together by meshing their teeth and turning each other in the system to generate the power and speed. It reduces the speed, increase the torque, and vice versa is also possible. And types of gear train: simple gear train, compound gear train, reverted gear train, and planetary gear train. So simple gear train we can define it is the basically a most common available gear train, in which the gear pair connecting a parallel shaft. The teeth of this type can be spur gear, helical gear, or the herringbone gear. Because there is a parallel shaft, matting gear having the parallel shaft, so this kind of gear we can use here. And only one gear may rotates about a single axis. So let us see, this is a diagram for a simple gear train where gear one it is connected with the gear 2 and 2 with the 3 and 3 with the 4 and 4 with the 5, and we get the output at the 5. So simple gear train, this is the arrangement of the simple gear train, and here we can find the train value. So we can calculate the train value of the gear train. Here there are two variable T and N, where T is the number of teeth on a gear and N is the speed of a gear in the RPM. So we can say the train value N2 upon N1. If I'm talking about this first matting gear, first pair of matting gear 1 and 2, so it would be N2 upon N1, T1 upon T2. Okay. So similarly for 2 and 3, we can write N3 upon N2 equal to T2 upon T3. For 4 and 3, it's become N4 upon N3 and T3 upon T4. And for the last one, last pair, we can also write N5 upon N4, T4 upon T5. And all the component just multiply both left and right side. So we can see here, you can see like N2, this will be cancel out this, and 3 and 4 and this one also. So what is remaining? It is N5 upon N1, and here you can see you can see that this T3 and this T4 and T4 and T2 and T2 is also cancelled out. So this value N in this simple gear train, the train value is N5 upon N1 equal to T1 upon T5. Okay, so we can see the number of teeth, number of teeth on the driving gear and number of teeth on the driven gear. And speed ratio we can calculate. It is the reciprocal of the train value. So we can write N1 upon N5 equal to T5 upon T1. That reciprocal of train value, that we call as the speed ratio. Okay. So let's see in the next slide, that is compound gear train. So in the compound gear train, the simple arrangement you can see here, where the two or sometime more gear are mounted in one shaft. This is, you can see 2 and 3 gear are mounted in the one shaft, and 3 and 4 and 5 are mounted in the one shaft. So let's talk about the compound gear train. So when a series of gears are connected in such a way that two or more gears rotate about an axis with the same amount of speed, it is known as compound gear train. Large velocity compound gear arrangement is preferred. So the two or more gear may rotate about a single axis. Okay, we already discussed that. So here you can see. So now we calculate the train value. So what will we do? What we have done in the last slide, and here we will do the same. So what gear 1 is attached with the gear 2. So what will be train value? That is N2 upon N1 equal to, that is N2, simply we can say N2 upon N1 equal to T1 upon T2. Okay, and here gear 3 is in contact with the 4. So also you can write N4 upon N3, N4 upon N3 upon T3 upon T4. But one thing you have to be remembered, the speed of gear 2 and gear 3 would be same because they are mounted in the same shaft. And here speed of gear 4 and 5 would be same. The reason is same because they are mounted with the same shaft. So hope you understand here the concept what I'd like to be explained here. So let us discuss in detail in the next slide. Okay, the same things what I have written in the last slide. So you can see the N2 is N and the T. So that gear 1 is connected to gear 2. So we can write N2 upon N1 is equal to T1 upon T2, and 4 is connected to the 3. So Tn N4 upon N3 is T3 upon T4, and similarly N6 upon N5 and T5 upon T6. Same, just multiply all the things. So you can see here this and 1, 2 and 3 are mounted with the same shaft, so it both are the same. Speed will be same, so we will cancel out to each other. And okay, so 2 and 3, and that 3 and 5 is also mounted with the same shaft, so that N4 and N5 speed same. It will same, and either here 2 and 3 speed will same. So let's, here you can see here nothing is going to be cancelled out, so that we can write here. So N6 upon N1, T1 upon T2, T3 upon T4, and T5 upon T6. So we can say in short, the product of number of teeth on driving gear upon the product of number of teeth on the driven gear. So let's discuss about reverted gear train. So that reverted gear train, when the axis of first gear, this one first, and the last gear is a number of fourth number, are coexistent, then gear is train is known as reverted gear train. So let's see something. So we can mention T1 is the number of teeth in gear 1, R1 is the pitch circle radius of gear 1, N1 is the speed of the gear 2, and similarly T2, T3, T4 for number of teeth for gear respective, and the pitch circle radius is for the respective gear 2, 3, and R1, R2, sorry, R2, R3, and R4, and similarly here the speed of the respective gear are N2, N3. So let's see next. So one thing is, you can see here, all that R1, the R1, if the distance from here, you can see the pitch circle radius means R1 is this, and it is connected to that R2. So this central distance you can see. So we can write R1 plus R2. Similarly, this 3 is connected to the R, 3 is connected to the 4. So we can say this radius of 3 which come to here and 4 which come to here, 8. So that would be R3 plus R4. So we in short we can write so that this distance is constant for the both. So we can say R1 plus R2 equal to R3 plus R4. Also, the circular pitch module, all the gear is assumed to be same. Okay, we can say that when the gear, the size of the number of teeth on the gear is dependent on the size of the gear. You can say. So as this relation is like this, so we can also rewrite as T1 plus T2 equal to T3 plus T4. That is simple fundamental things well understood. And speed, that speed ratio, that is it is a reciprocal of what, um, train value. Okay, so we can write speed ratio is n1 upon n4 because n1 and is input and n4 is output. So directly we can write like this, and t2 into t4, the product of number of teeth on the driven shaft and product of number of teeth on the driving shaft. Okay, driver. So this last one is that epicyclic gear train. So if you see such kind of arrangement, a train having the relative motion is called planetary or epicyclic gear train. In the epicyclic gear train, axis of at least one of the gear also move related to the train. Okay, so this arrangement you can see here. One S gear, second one is the P, and this they are connected with the arm A. So if the arm A is fixed, if you made it fixed, so this type of arrangement is called a simple gear. If if S is fixed and arm start rotating around this, so this kind of arrangement is called the planetary gear train, or you can see epicyclic gear train. Okay, so this so epicyclic gear train are useful for transmitting high velocity ratio, and gear of moderate side is a comparatively less space, and such kind of arrangement can be made it. Okay, so wristwatch, basically in the automobile sector where it's such kind of arrangement mostly are used. So thank you so much all of you for listening this lecture.